The universe is playing a trick on us. Or maybe we've been telling ourselves the wrong story all along. Because deep in the distant glow of the early cosmos, the James Webb Space Telescope has found something that shouldn't be there. Galaxies. Big ones. Mature ones. Packed with stars, structure, and even signs of ancient starlight. Showing up just a few 100 million years after the Big Bang. According to everything we thought we knew, these galaxies didn't have enough time to form. They're like skyscrapers built in a day, cities rising before the roads were paved. And now, scientists around the world are asking a terrifyingly exciting question. Did we get the universe wrong? For decades, cosmologists have worked with a model called Lambda-CDM, the standard model of cosmology. It's not a flashy name, but it's the most successful explanation we've ever had for how the universe evolved from a hot, dense beginning into the vast, structured cosmos we see today. In this story, the early universe was simple and chaotic. Tiny clumps of hydrogen and helium gas floated in the dark, slowly pulled together by gravity. Over millions of years, those clumps collapsed, ignited the first stars, and formed small, messy galaxies. These baby galaxies then merged, collided, and gradually built up into the massive spiral and elliptical galaxies we see billions of years later, like our Milky Way. It's a slow, step-by-step process, like building a civilization from scratch. You don't get libraries, power grids, and space programs on day one, but what JWST is seeing looks nothing like that. It's seeing fully formed civilizations in the earliest chapters of the cosmic story. Galaxies like JADES, GSZ13JO, Sears 119, and Glass Z12 appear shockingly massive and well-organized, existing when the universe was only about 300 to 400 million years old. That's less than 3% of its current age. And yet these galaxies contain billions of stars, some with signs of heavy elements like oxygen, carbon, and even neon. That's a huge problem because those elements aren't born in the Big Bang. They're forged inside stars over millions of years and scattered into space when stars explode as supernovae. It takes multiple generations of stars to build up that kind of chemical richness. So finding them this early is like walking into a forest and finding ancient oaks, when the first seeds were only planted yesterday. At first, scientists hoped it was a mistake. Maybe the distances were wrong. Maybe these galaxies weren't actually that far away. But JWST doesn't just take pretty pictures. It analyzes light with incredible precision. Its spectrographs have confirmed the redshifts of these galaxies, proving they really are from the universe's infancy. The data is solid. The galaxies are real, and they're too big, too bright, and too mature to fit into our current models. So what does that mean? It means we might be facing one of those rare moments in science when a single discovery forces us to rethink everything. It's like realizing your map of the world is missing a whole continent. And now, researchers are scrambling to figure out how the universe pulled this off. One possibility? Dark matter might not be what we thought. Dark matter is the invisible scaffolding of the cosmos. It doesn't shine, but its gravity shapes how galaxies form. In our standard model, dark matter is cold, meaning its particles move slowly and clump gradually. But what if it was warmer in the beginning? Faster moving particles could have created denser cores earlier, pulling in gas and stars at a much faster rate. That could jumpstart galaxy formation, allowing massive systems to appear far sooner than expected. It's a small tweak in theory, but it could explain a lot, though it risks breaking other parts of the model that currently work very well, like the cosmic microwave background patterns we see from the infant universe. Another idea involves black holes, not as destroyers, but as creators. We used to think supermassive black holes grew slowly over time, feeding on stars and gas. But what if some were born big? A giant cloud of pristine gas could collapse directly into a black hole weighing tens of thousands, or even millions of times the mass of our sun, no star phase needed. These direct collapse black holes could then act like cosmic engines, pulling in material and triggering intense bursts of star formation around them. JWST has already spotted unusually bright, compact objects in some of these early galaxies, possible signs of such massive black holes already lighting up as quasars. If that's true, black holes weren't just a product of galaxy evolution. They might have been the spark that started it. Then there's the possibility that the early universe was just a far more efficient star factory than we imagined. Conditions back then were extreme. Gas was denser, gravity was stronger in small regions, and there was no pollution from previous generations of stars to slow things down. Some models suggest that in these pristine environments, stars could have formed at rates hundreds of times faster than today. Entire galaxies could have lit up in just a few million years, a blink in cosmic time. It's like the universe hit fast forward. And if that happened across multiple regions at once, we'd end up with a surprising number of large galaxies early on. There's even a more radical idea floating around. What if our understanding of gravity itself needs an update? Einstein's theory works incredibly well, but it doesn't explain everything, especially at the largest scales. Some physicists have proposed alternative models, like modified Newtonian dynamics, or MOND, where gravity behaves differently in very low-density environments. In these models, galaxies could form faster without needing as much dark matter. Recent simulations combining MOND-like gravity with early universe conditions have actually produced massive galaxies surprisingly early, matching what JWST is seeing. It's still a minority view, but it's gaining attention because it might solve multiple puzzles at once, including why some galaxies rotate the way they do without dark matter. Of course, not everyone is ready to rewrite cosmology just yet. Some scientists argue that we might be overestimating the masses of these galaxies. JWST sees in infrared, and when you're looking at distant objects, it can be hard to tell whether you're seeing one massive galaxy or several smaller ones overlapping, blending into a single blob. Also, the brightness of stars can be misleading. Early galaxies may have been filled with hot, massive stars that shine incredibly bright, but don't add much to the total mass. So what looks like a giant galaxy might actually be a smaller one glowing like a cosmic spotlight. But even if that's the case, the sheer number of these too big galaxies is hard to ignore. JWST wasn't designed to find them. We weren't even looking. And yet, they keep showing up. It's like walking into a forest expecting rabbits and finding elephants. At some point, you have to ask, is the forest different than we thought? And here's another twist. Some of these galaxies appear to be not forming stars as rapidly as expected. That's strange. If they're so mature, you'd think they'd be blazing with new star birth. But some look surprisingly calm, with older stellar populations. That suggests they formed their stars in a quick, intense burst, and then quieted down. A flash of creation followed by silence. That kind of burst and fade model is possible, but it requires very specific conditions. And it's not something our standard simulations predict often. So where does this leave us? In a place of beautiful uncertainty. The James Webb Space Telescope wasn't just built to confirm what we know, it was built to surprise us. And it's doing its job. These early massive galaxies might not disprove the Big Bang or destroy the Lambda-CDM model, but they're definitely stressing it. They're like cracks in a well-built wall, hinting that something behind it might need reinforcement. And that's how science moves forward. Not by clinging to old ideas, but by following the evidence, even when it leads to uncomfortable questions. Maybe we need to adjust dark matter. Maybe early black holes were more powerful. Maybe star formation was wilder than we thought. Or maybe, just maybe, there's a deeper layer of physics we haven't uncovered yet. What's exciting is that we're not stuck. JWST is still observing. New data is coming in every month. Astronomers are refining their models, running new simulations, and planning deeper surveys. We're also waiting for next-generation telescopes, like the Nancy Grace Roman Space Telescope and the extremely large telescope on the ground. That will give us even sharper views of these ancient galaxies. Soon, we might be able to resolve their shapes, map their star populations, and even detect the motion of their gas. That could tell us for sure whether they're truly massive or just look that way from far away. And here's a thought that keeps some cosmologists up at night. What if the age of the universe needs to be reevaluated? Right now, we say the universe is 13.8 billion years old, based on measurements of the cosmic microwave background. But if galaxies are forming faster than expected, does that mean the universe is older than we think? Or, more radically, could the expansion rate of the universe have been different in the beginning? There's already a tension in cosmology called the Hubble tension. A disagreement between how fast the universe appears to be expanding today versus how fast it should be expanding based on early universe data. If that tension is real, and if the early expansion was faster, then there might have been more time for galaxies to form in what we call the early universe. That could resolve the paradox, not by changing galaxy formation, but by changing our timeline. But that's a big step. Changing the age or expansion history of the universe affects everything, from particle physics to the fate of the cosmos. So most scientists are cautious. They'd rather adjust the details than rewrite the whole story. But history shows us that sometimes the details can't be adjusted enough. Sometimes a revolution is coming, quietly, one galaxy at a time. So the next time you look up at the night sky, remember those quiet stars and distant smudges of light in telescopes? They're not just passive objects, they're clues. Pieces of a cosmic puzzle that's still being assembled. And right now, we're living through a golden age of discovery, where a single telescope is forcing us to re-examine the story of the universe itself. If you found this journey into the early cosmos as mind-blowing as we did, please hit that like button. It really helps the channel. And if you haven't already, make sure to subscribe and turn on the bell so you don't miss our next deep dive into space, time, and the mysteries of the universe. We're just getting started. Until next time, keep looking up. Because the universe is stranger, older, and more wonderful than we ever thought possible.